Note that the second denominator, over there on the right, the third one I guess, is factorable into the first two denominators. I'm not going to write it all out. We know that x plus 3 times x minus 3 is the least common denominator that we're multiplying through by. Now let me talk about that for just a second. The reason we're allowed to do this is we're multiplying by the same value on each side of the equation. Whatever you do to the left side of the equation, you do to the right side of the equation, and it should still leave you with valid answers. Here we go. On the left, the x plus 3's cancel, leaving the 4x times the x minus 3. In the middle, we already have the minus 12. After the x minus 3's cancel, you've got the x plus 3 left over. And then on the right, everything cancels, just leaving the 4x squared plus 36, which was the original numerator to begin with. We have two sets of distribution here. So here we go, 4x squared minus 12x minus another 12x minus 36 equals 4x squared plus 36. Seeing these x squareds, the first thing that catches my attention is that upon trying to get them to the same side, they will cancel each other out when I subtract them off of each side. So all we have left are linear terms. So on the left we've got negative 24x minus 36. On the right we've got 36. Adding 36 to both sides, we now have negative 24x equals 72. And dividing by negative 24, we get negative 3. However, negative 3, when you substitute it into the first and third denominator, does not work. Therefore, we need to cross that off, and we have no solution in this problem. I can spell solution, whatever, you know what it is. Here we go. Next problem. X minus 1 is the common denominator. We're going to multiply through by x minus 1 on each side. And basically that's going to cancel out the denominators, and we're going to be left with x squared plus 3x on the left and just the 4 on the right. This is a quadratic equation which needs to be set equal to 0, so we're going to subtract the 4 on each side. Factoring, we have x plus 4 times x minus 1 equals 0, and it appears that our answers are negative 4 and positive 1. But upon checking our answers, we notice that 1 is an extraneous solution and needs to be crossed off, leaving just the negative 4. Okay, this is worth a comment here. All the previous problems had 3 fractions in them. This is just 2 fractions, and usually when we have 2 fractions, we cross multiply to solve these proportions. Had we cross multiplied on this problem, notice that on one of the diagonals, x squared times x would have given you an x to the 3rd cubic equation, which would have been a little bit messier to solve. So actually, rather than cross multiplying, using this process of multiplying through by the least common denominator is a nicer way to go most often. Number 6. We're going to multiply through by the least common denominator, which is 6y. On the left, the 2y cancels with the 6y, leaving 3 times the y plus 1 that's already there. On the right, the 3 cancels with the 6y, making 2 times 2y. Now let's stop there for just a second. Notice what we get here. This is what we would have had anyways had we cross-multiplied. Notice each diagonal is represented here. Okay, end of our little side trip there. 3y plus 3 upon distribution equals 4y. Let's subtract the 3y off both sides, and we get y equals 3 as our solo solution. Now I want to make a quick comment here about solving rational equations. Let's say we had 2/3 plus 1/4. You know that we're supposed to add these together over a common denominator. This is not an equation. However, what happens is people get the first half of this chapter and the second half of this chapter confused in their brains. And what they do is they say, ooh, 3 times 4, let's multiply through by 12. And then they cancel the 12 and the 3, and they get a 4 there. They cancel these, and they get a 3 there. And they say, 4 times 2 is 8. 3 times 1 is 3. And they say, my answer, 2/3 plus 1/4 is 11. Okay, you might be laughing along with me here. The answer is not 11. It's 11/12. Rational equations, you get rid of the denominator by multiplying through by the least common denominator. But for rational expressions, addition and subtraction, you keep the common denominator. See, what allowed us to multiply through on 12 by 12 on both sides is there had been an equal sign in the middle, not a plus sign. And you're allowed to multiply on both sides of an equation by the same thing. This is not an equation, and you could not treat it as such. This problem, we were technically supposed to have said, let's rewrite each of these over 12. Make this an 8/12 plus 3/12 and gotten the 11/12 that way. So watch out. This whole section is going to be filled with equations, so you'll be multiplying through to clear the denominators. But at the end of the chapter, when everything's kind of all scrambled up, you've got to watch the directions. Here again, the directions would be add, whereas if there had been an equal sign in the middle, the directions would have been solve.